Hello, biology class. Mr. Adair here, and we will be starting a sequence of guided notes over the next few days for you to learn about cycles in nature, including the water cycle, which I will be talking about today. So take a moment and open up your guided notes in Notability. If you need to pause this video, you can do that right now. And the guided notes in Notability will correspond with each slide on here so you can follow along. So right now you can pause the video, open up your guided notes in Schoology, and be ready to take some guided notes on the water cycle. Okay, we will be talking about cycles in nature, including the water cycle, which many of you have learned this information in middle school and even somewhat in elementary school, but we will be taking it a little bit further. Um, First of all, cycles of matter, what are we talking about? In order for life to exist on Earth, we need nutrients and matter to kind of change forms and recycle through. So if you remember what matter is going to be atoms and molecules that make up the world around us. So this is your first information for the guided notes. The the three cycles we will be talking about for this unit, ecology unit, will be the water cycle, the carbon cycle, and the nitrogen cycle. And today we will be talking about just the water cycle. So make sure I'm giving you, we'll kind of go slow, but for the first guided note, your answer will be the carbon cycle. That's one of the three cycles we'll be talking about. That will be later next week. All right, let me move my screen here. Here is a diagram of the water cycle. And I want you to think about this. Planet Earth, we live in a closed system. So all of the matter on Earth, the carbon, the hydrogen, the oxygen, it stays on Earth. The only way we get new matter is if like an asteroid hits Earth or something from outer space hits Earth, or if we launch something into outer space, then we'll lose matter. But otherwise, the Earth is a closed system. So all of the water, the H2O on Earth, it cycles. It can be in the ground, it can be inside plants, it can be in lakes and rivers, it can be in the oceans, it can be in the clouds, and we'll talk more about that a little bit. So we live in a closed system, and H2O, which is a water molecule, cycles through the environment. So if you need to pause the video now to make sure that you're getting your guided notes by reading this information, you can do so. Okay, moving on. Slide number 3 for your guided notes, the water cycle. So now, very simply, the water cycle is the movement of water among the oceans, the atmosphere, the land, and living things. The cycling of this matter helps us to support life. Another word for support is sustain, meaning it keeps it going, keeps life on Earth going. One of the first vocab words, as you may know, precipitation, which means water that is either raining, snowing, or sleeting down. So when water evaporates from lakes or oceans or rivers, it will change from liquid form to gas form and exist in the air like the clouds. And when so much of that water in the clouds gets so heavy and all those H2O molecules are in the gas form, at some point it forms bigger clouds, heavy clouds. It gets very full and heavy, and that's when the water will then change forms again to from gas form to again liquid form in rain, snow, or sleet. This is going to be an important thing to remember for later when you're thinking about some of this. When it rains, snows, or sleets, 91% of that water falls into the ocean. The other 9% falls on the land and renews our freshwater supply. So again, water doesn't really go anywhere on Earth. It just changes from one form to another. When the rain or snow or sleet falls on land, that replenishes our groundwater. It replenishes the water that we use for drinking and watering crops and so on and so forth. So if you need to pause the video now, you can to answer number 3. the fourth part of your guided notes, a couple more vocab words. Evaporation is where heat causes water to change from liquid to vapor. You see this whenever you boil water to make macaroni and cheese or anything like that. Condensation, water vapor becoming liquid, again, due to the cooling of the atmosphere. So then the evaporated water will cool down and change forms back into rain, water, or sleet, or condense sometimes on your grass in the spring. Now, another word that maybe you haven't seen or heard in a long time or ever is the word transpiration. That's when water is moving from living things back into the atmosphere. This is where water actually in the leaves of plants transpires from being in the liquid form inside the plant, and then it will go from being in the plant into the atmosphere through the process of transpiration. So you can also put that down for your guided notes today. Feel free to pause the video now. I'm going to keep on moving. Okay, the water cycle. Now, another thing to know is we have water that is in the groundwater, obviously. This is where the water seeps into the ground and is stored in underground caverns, or a lot of times it's stored in porous rock. Porous means like a good example would be sand is very porous. If you notice, you can put water in sand and that sand will hold some of the water. You can also do it in other rocks and soil and dirt. So a lot of the groundwater is going to be held in sand, soil, things like that. Now this groundwater provides water for when we for trees, a lot of times for streams, rivers, and oceans. So not only does water exist on the surface and in the air, it also exists underground. Okay, and that will be important when we talk about agriculture and things like that in a little bit. Our water supply is not getting larger. Remember, we only have the same amount of water on Earth, but we must protect our fresh water from pollution, and we'll get to that more later. And we also must conserve our fresh water so we have enough of it to water our crops and to have fresh water to drink. Okay, I want to talk a little bit more about that now. Why it's important that we conserve water. Now in Minnesota, we get a lot of rain. In fact, it was raining today when I made this video. But we don't have endless supplies of water on land and or underground. Another term for thinking about underground, we call underground water aquifers also. An aquifer is a large area of stored water underneath the ground. If you look at this map of the United States, we see that the region in blue is called actually the Ogallala Aquifer. And this is a very, very large aquifer, tons of groundwater underneath. And this is important to know about because this is the aquifer that a lot of farmers in the Midwest use to water their crops in Nebraska, Colorado, Kansas, Oklahoma, New Mexico, and Texas, South Dakota too. And the reason it's very important is because we are actually using too much water too quickly out of this aquifer, and it really is very important to supplying our crops, and we'll get to that in a minute because I want you to think about this as we go. So for agriculture, when we grow our soybeans, our corn, other tomatoes, all sorts of plants that we use for eating or for feeding animals that eat, we pump a lot of that water from underground, from the aquifers. In fact, in the United States, a lot from the Ogallala Aquifer. Now, we are using this water much faster than it is recharging. Recharging is a word meaning for the water to replace itself. Now, how does the water replace itself? Well, it must fall on the ground from rain, and the rain will seep through the soil into the aquifer to replenish the aquifer. So we are using up water from the Ogallala Aquifer for agriculture faster than it recharges. Should we be concerned about this, and why? So for number 7 on your guided notes, I want you to write a couple of sentences that maybe shows why you think we should or maybe should not be concerned about this. Keep in mind that we need that fresh water for plants. So pause the video now and take a moment to answer this question. Think about it a little bit. I really want to hear what your thoughts are. And now the last thing I want you to think about for today's mini lecture is water usage. So we now know that water cycles. Liquid water evaporates to gaseous water. Gaseous water precipitates and falls as snow or rain. Let me move this here. If water continues to go through a cycle, then why should we be worried about the Ogallala Aquifer running out of water? If we know that water doesn't ever leave Earth, because remember, Earth is a closed system, do we need to be concerned about the water supply? Because doesn't water just go from being on the land or in the oceans and evaporates into the clouds, and then the clouds rain, and the water just continues to go through that cycle. So should we actually be concerned about water shortage? I want you to think about this and write your response for question number 8. And in the next slideshow that I do guided notes, we'll talk more about this. I'll open up with this. But I really want you to think. I want to see what your answers are. Why do we need to be concerned about water shortages? Does it have to do with fresh water versus ocean water? Think about the slide that I showed you also earlier. Where does most of the water fall? So that's the big hint I'm going to give you. So today you learned a little bit about the water cycle, which you probably knew something about already. The next guided notes for next week will be on the carbon cycle, and we're going to relate that to climate change and greenhouse gases. And then we'll talk about the nitrogen cycle later also. Other atoms and matter do cycle through the environment, but we are going to focus on the water, carbon, and nitrogen cycle. I hope you learned something today about the water cycle. To get started, please do your guided notes and get them turned in. I hope you are all doing well. I miss you very much. And please call or email me if you need anything. I can set up an individual Google Meet. And in addition, during our scheduled class times throughout the week, I always put our Google Meet link on Schoology so you can check in during that time if you're available. Alrighty, thank you.